Okay, so let's consider a second example here with the geometric sequence, 4/3 to the n. So we're going to look at that limit. So limit as x goes to infinity of 4/3 to the x. So to do that limit, rewrite that in terms of e like we did in the problem above. So that's going to be limit as x goes to infinity of e to the ln of 4/3 times x. But ln of 4/3 is a positive number. So this is e to a positive power now. And so as x goes to infinity, e to that positive power is also going to go to positive infinity. So this 4/3 to the n, where the ratio is 4/3, diverges. It does not converge. It does not converge. And so we can actually summarize the geometric sequence as follows. Based on these two examples, here's what happens with the geometric sequence. Geometric sequence. Okay. So this is the sequence a sub n equals a times r to the n. Okay. So if the ratio is less than 1, its absolute value is less than 1, then you're going to converge to 0. You're going to converge to 0. If the ratio is bigger than 1, its absolute value, then it's going to diverge. We saw that with the 4/3. What's going to happen if r is negative? That just introduces an alternating idea into it. So if this had been negative 4/3 to the n, well, we would look first at the 4/3, say, oh, that goes to infinity, so the whole thing diverges. If the problem up above here had a ratio of negative 2/3, and that was negative 2/3 of the n, we'd have worked it out first with the 2/3, saw that it went to 0, and we'd have said, oh, the negative 2/3, well, that's alternating sign, but it's going to 0, so the whole thing's going to go to 0 anyway. So that's what's going on here with these two absolute values. And then there's two other possibilities we have to consider. And that is, if the ratio is 1, then you got a pretty boring sequence. It's just going to converge to a. Every value is a. And the final possibility here is that r equals negative 1. That would, of course, diverge, because if r was a negative 1, your sequence would just keep alternating between minus a and a. So, of course, it wouldn't converge. So with a geometric sequence, it's only going to converge to a value if the ratio is less than 1. Otherwise, it's going to diverge.